Hello, geometry students. Mrs. Myers here. Today is our first day of doing 3 lessons on coordinate geometry proofs, and then one more lesson on working with coordinate geometry formulas. So it's really 4 days total. So it'll be both Tuesday and Thursday of this week and Tuesday and Thursday of next week. At the conclusion of these 4 lessons, though, we will be done with Mod 4, and then we will be moving on to a new module, and we'll have probably one of those like CAS Learning quizzes or something of the sort, okay? So anyway, what you are looking at right now for the first part of what we're doing today are the conditions for a parallelogram, okay? You've already seen this, okay? There are 5 different ways that you can prove that a quadrilateral is a parallelogram. Let me remind you of them. This is a little chart here, but we're not actually going to be using all 5 when it comes to coordinate geometry proofs, okay? So I'll go through and tell you which ones we would use and which ones we wouldn't. So the first one that says both pairs of opposite sides are parallel, that one is a biggie, okay? We would use that one often, okay, for coordinate geometry proofs. You could also prove that both pairs of opposite sides are congruent, okay? That's enough to say that you have a parallelogram. Again, that one, absolutely. Okay, let's check that one off. Both pairs of opposite angles are congruent, although that is a good way to prove that you have a parallelogram from, just regular old geometry facts. This is not going to be used when it comes to coordinate geometry proofs. Okay, the diagonals bisect each other. That's a good one. It's actually the shortest of all the reasons to use for coordinate geometry proofs. And then one pair of opposite sides is congruent and parallel at the same time. Absolutely. That's just really a mix of the first 2 put together. So that one could absolutely be used. Although I'm not going to illustrate that one per se with my 3 different examples here, because again, it's really just a mix of the first 2. All right. So within all the lessons that we've been doing so far here and there in Mod 4, we have seen 3 different coordinate geometry formulas so far. We're going to use each one of them to prove that we've got ourselves a parallelogram from 4 vertices of a quadrilateral. So the first thing you always want to do is you want to make a diagram for yourself. Now, if you have graph paper, go right ahead and do it on graph paper. Even if you don't, you can kind of just make a little sketch off to the side here. So that's what I'm going to do, okay? So we are going to plot these points. Okay, A is -2, 3. Okay, so there's A. B is 3, 2. Okay, C is 2, -1. And D is -3, 0. Okay, what I else think is a great idea is to have the coordinates listed right beside each of the points. Okay, it'll make it easy for us when we're doing our work if we have that right there in the diagram. Okay, so I suggest you do that as well. So anyway, the first of 3 methods is to prove that you have a parallelogram by using the slope formula. So if you recall from when we were doing this work throughout this module, the slope formula can be used to prove that lines are parallel or that lines are perpendicular. Okay, in this case, we're going to prove parallelism with the slope formula, because if both pairs of opposite sides are parallel, then we would have ourselves a parallelogram. Okay, the opposite sides, that's important to note, right? The opposite sides. So slope formula is, I'll write this off to the side here, just as a reminder, y2 minus y1 over x2 minus x1. Okay, so we're going to use the slope formula to show that both pairs of opposite sides are parallel. So first we're going to do the slope of side AB. So I'm going to always be clear with my work. Okay, so I'm going to go slope of, and then I'm just going to put segment AB. Now, it doesn't really matter which point I call x1, y1 and which point I call x2, y2. I'm going to just make sure I subtract in the same order. So for example, I can look at these y coordinates and say, oh, I'd like to do 3 minus 2 as y2 minus y1 in the numerator. Well, then that's fine. But then you're just going to make sure you do the same order with the x's. You're going to go -2 minus the 3. Okay, and then see what you get. Okay, so you get 1 over -5, which is obviously -1/5, okay? Now, right next to it, I'm going to do the slope of the side that's opposite from that right away, because what I'm trying to do is I'm trying to prove that the opposite sides are parallel. So what do we need to know about slopes if the lines are going to be parallel, right? Do we recall this? We need to see that the lines have the same slopes, okay? Same slopes means parallel. So let's look at these 2 points. Okay, let's decide how we're going to subtract the y's. So for example, I could go 0 minus negative 1 for the y's. Okay, so if I go y2 minus y1 is 0 minus negative 1, then I'm going to go negative 3 minus 2. Okay, and let's just see what I get. So 0 minus negative 1 is positive 1, and negative 3 minus 2 is negative 5. Okay, so notice these slopes are both negative 1/5. So what does that mean? Okay, so here's what I'm going to do. Remember, we would always write statements and reasons and everything with our proofs from much earlier in the year. Well, we're going to write a little statement and a reason. We're going to say that AB is parallel to CD, and then the reason, okay, that we're going to write right after it, you can use this in parentheses underneath it, is we're going to say same slopes. Okay, that's sufficient. All right, now we're going to keep going because it's not just enough to have one pair of opposite sides parallel. We need both pairs of opposite sides parallel. So we're going to write down slope of, now let's go to side BC. Okay, so I'm going to go 2 minus negative 1, for example, for the subtraction of the y's, and then I'm going to go 3 minus 2 for the subtraction of the x's. So 2 minus negative 1 is 3, 3 minus 2 is 1. Now, right next to that, I just want to be nice and neat and organized with my work, is the slope of segment AD. Okay, so what are the difference of the y's? I can go, for example, 3 minus 0. Now, if I do that, though, all right, and I go 3 minus 0, and then I'm going to make sure I do the subtraction and the x's the same way. So negative 2 minus negative 3. So 3 minus 0 is 3. Negative 2 minus negative 3 is 1. And what do I notice about these slopes? I see that they're the same. So I write my statement, BC parallel to AD, y, same slopes, right? And then I need a conclusion statement, okay? I need an overall conclusion statement. So what does it mean about this quadrilateral if I have both pairs of opposite sides parallel? Well, what I now know then is the figure is a parallelogram because both pairs of opposite sides are parallel. So I write that down. I'd write down quad ABCD is a parallelogram because both pairs of opposite sides are parallel. Okay, so that is one particular way of doing this coordinate geometry proof. Okay, now in the long run, okay, like in the end result here, okay, when we do, like, let's say like a quiz, if I ask you to prove that we have a parallelogram, that would be sufficient. Okay, if you like this method the best of all three that I'm showing you, you would just use that, and you would not need to use anything else. Now for the homework though, I am going to ask you to prove that you have a parallelogram using all three of the methods. I want to make sure you practice all of them for the very, very first assignment, okay? But now let's go on to method 2, okay? You can use the distance formula, and if you recall why we did the distance formula before, it was to get the length of a segment. Now, if two lengths of segments are the same, if two segments have the same length, then what would that mean? It would mean that they are congruent. So we want to prove, just like we did here, that both pairs of opposite sides are congruent by getting the same lengths, not the same slopes, but the same length. So I'm just going to do the same thing, but with a different formula. Now the distance formula is, okay, square root of, so distance equals, okay, in parentheses, x2 minus x1 quantity squared, plus in parentheses, y2 minus y1 quantity squared. You make sure all that's underneath your square root symbol, okay? Now, I don't need to write distance of for these four sides. I can just go AB like that without putting a bar over it. If you remember back from the beginning of the year, that means that you are finding the length of a segment. Okay, so now I just set myself up, okay, with, you know, what's going to look like the substitution of the coordinates in the distance formula, okay? So I come back here, now I'm doing the x's first, okay? So I can subtract those x's from points A and B in any order that I want, but I'm just going to be consistent with subtracting the y's in the same order as well. So if I want to go 3 minus negative 2, for example, then I'm just going to go 2 minus 3 for the subtraction of the y's, okay? And then I've got 3 minus negative 2 is 5. Notice how I'm keeping those parentheses, okay, even though it's positive. 2 minus 3 is negative 1. Again, notice how I'm keeping those parentheses, and that's absolutely needed, okay, because it's the negative. Now I square each number, so that's 25 and that's 1. Then I add it together, Okay, so the distance is square root 26. Now that is not a nice rational number, and I just leave it. Okay, do not need to change that into a decimal. That is just extra stuff that you just don't even need to do. So what we're going to do now is we're going to compare this length, okay, the side length of AB, to the side length that's opposite from it. So CD, okay, what does that length equal? So I get myself all set up, okay, with what the distance formula looks like. Okay, so I'm going to do the subtraction of the x's, then square that, the subtraction of the y's, then square that, add them together and square root it. Now for segment CD, again, it doesn't matter what order I subtract the coordinates, and I'm just going to be consistent. So if I want to go 2 minus negative 3, then I would go negative 1 minus 0. Okay, so now I do the subtraction. 2 minus negative 3 is really 5. Keep that in parentheses. Negative 1 minus 0 is just negative 1. Again, keep that in parentheses. Make sure that square root keeps going over the whole thing. Now square each number. So 25 and 1. Okay, any number squared is always positive. And then add them together. Okay, so again, all I'm really doing is comparing these distances. Okay, so these opposite sides have the exact same length. See, the distance between each of the endpoints A and B here is the same as the distance between each of the endpoints here. So these lengths are the same. So what I say is that segment AB is congruent to segment CD, and I'm going to say same lengths or equal lengths. Okay, now I'm going to do that again, but for the other pair of opposite sides. So first I'm going to do side BC. Okay, what is that? Okay, so I get myself all set up, and I'm just going to look at these x's and go 3 minus 2. And I'm going to subtract the y's the same way, 2 minus negative 1. And then I subtract 3 minus 2 is 1, 2 minus negative 1 is 3, right? Add the opposite. Okay, again, make sure that square root keeps going over the whole thing. Then do the squaring. 1 squared is 1, 3 squared is 9. Then add them together, and that's square root of 10. Again, just leave it. Okay, leave it. Now let's compare that to the side that's across from it. So AD. Okay, get yourself all set up. Okay, with your square root symbol and your parentheses with the squaring and everything. Now I'm going to go to AD, and I'm going to, for example, go negative 2 minus negative 3. And then I'm going to go 3 minus 0. And then I'm just going to do this subtracting. So negative 2 minus negative 3, that really means 1. 3 minus 0 is just 3. Now do the squaring. 1 and 9, right? 1 squared is 1, 3 squared is 9. Now add them together and get square root of 10. All right, and then just compare these lengths. Okay, what do you notice about the length of segment BC to the length of segment AD? They're the same lengths. So what does that mean about these segments? It means that they are congruent, okay? And then what's the reason? Is that they have the same lengths, okay, equal lengths. That's why I know that they're congruent. And now I'm going to write my overall conclusion statement. So if I have both pairs of opposite sides of a quadrilateral to be congruent, what does that mean about the quadrilateral? It means it's a parallelogram. So I just write the same thing. I go quad ABCD is a parallelogram, okay, because both pairs of opposite sides are, and this time notice I say congruent. See, before here I said parallel, okay, because that's what I was doing, is a slope formula. I was proving parallelism. Now I say congruent, okay? So last method to prove a parallelogram, and again, for your homework, you're going to use all 3 methods to do the homework, okay, this very first problem, but in the future, if you're asked to prove that you have a parallelogram and it doesn't tell you which method, you could choose any one that you want, okay? So for example, if you just like that distance formula better than the slope formula, then you would use that method instead. But anyway, here's the last one, okay? There's 3 different ways to do it. There's 3 different coordinate geometry formulas that can make this happen. So we are going to use the midpoint formula, okay, to prove that the diagonals bisect each other. Now, how we're going to do that is the midpoint is the point that's halfway between the endpoints, right? The word bisect means to cut in half. So if these diagonals, AC and BD, share the same midpoint, so like point E, for example, like that's quote unquote what we're trying to find, if that's the same coordinate for each diagonal, then we can say that the diagonals have bisected each other. So we are going to write down here, midpoint of segment AC, and then we're going to do midpoint of segment BD. Make sure you do this with the diagonal. So what is your midpoint formula. Okay, the midpoint formula is, in parentheses, x1 minus x2, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Okay, and that's all inside a set of parentheses. Now, technically, there is another midpoint formula. Remember, we talked about two different formulas for midpoint, one that could be used for any point with another directed line segment, not just the halfway point. But to be honest, if you're very specifically finding the midpoint formula, this is the easier, more straightforward one to use. If you prefer the other one, you certainly could use that. Okay, let me remind you of that. That would be x1 plus half of x2 minus x1, comma, y1 plus half of y2 minus y1. Okay, but again, notice that that's a little bit, more work to do there. So typically we reserve this one for finding a point that's on the directed line segment that's not necessarily the halfway point, like the point that's 1/3 of the way, the point that's 3/4 of the way, etc., because then you would just change that fraction to whatever that is. Although, again, it can be for finding the midpoint. I just think it's a little bit longer formula. I think this one's more straightforward. So anyways, let's just go to our work. Okay, AC, this diagonal right here. Okay, its midpoint is the average of the x coordinates. So in parentheses, -2 plus 2 divided by 2, comma, average the y coordinates. So 3 plus -1 divided by 2. So -2 plus 2 is 0 divided by 2, right? 3 plus 1 is 2 divided by 2. And then 0 divides by anything to be 0, 2 divides by 2 to be 1. So that's the midpoint of AC. Now let's compare it to the midpoint of BD. Okay, so we are going to average the x coordinates, so 3 and -3. Add that together, divide by 2. Average the y coordinates, okay, 2 plus 0 divided by 2, okay? And then see what you get. So this is 0 divided by 2, this is 2 divided by 2, this is 0, this is 1. Notice that they're the same, okay? So what we say here as far as a statement and reason is we would say AC and BD bisect each other, okay? And then we would say the reason is same midpoint. And then we would have our overall conclusion statement, which is quadrilateral ABCD is a parallelogram because, I'm running out of room, so I'm going to write underneath here, because the diagonals bisect each other. All right, so take a good look at that. Okay, those are, again, the 3 different methods for proving that you have a parallelogram, and you are going to do all 3 for the problem, for the homework problem. But there's one more thing that we're going to put into day 1 of this. All right, and that is, once you've proven, okay, let me repeat that again. Once you've proven that you have a parallelogram, how can you prove that you have a very special type of parallelogram called the rectangle? Okay, so very, very specifically, the rectangle is a special type of parallelogram. Okay, day 2, we'll do some other special types of parallelograms. For today, it's just a rectangle. So we've got 2 different ways of doing this, okay? So this is like an or. Do one or the other, okay, if you're given a choice. So if one angle of the parallelogram is a right angle, okay, then automatically the parallelogram would be a rectangle, okay? Given that all the opposite angles of a parallelogram are congruent, and given that the consecutive angles of a parallelogram are supplementary, and supplementary means add to be 180, as soon as you get one angle to be a right angle, then all of them would have to be right angles, and you would automatically have a rectangle, okay? The other method to do it is that the diagonals are congruent, okay? If you can prove that the diagonals of the parallelogram are congruent, then it would have to be a rectangle, all right? So once again, I'm going to just suggest that we make a little sketch here just to see what it is that we're looking at. Okay, it can be on graph paper for nice accuracy, or just a quick little sketch off the side of your paper would be sufficient just to kind of see. So A is -3, 0. Okay, B is -2, 3. C is 4, 1. And D is 3, -2. Okay, so we're going to just connect these points. Again, put the coordinates right next to each of the points I think it's going to make it a lot easier for you to have that when you're doing the work with the formulas. All right, so there you go. Get yourself a nice little sketch. And we're going to do method 1, which is the slope formula. That is not just used for parallelism, that's proved for perpendicularity as well. So when you have a right angle, again, remember that is the definition of the word perpendicular, right? When two line segments are perpendicular, they form a right angle. So we just need any angle to be a right angle. So for example, if we want to prove that's a right angle, doesn't really matter which one, okay? Then what we're going to do is we're going to find the slope of side AB, and we're going to compare it to the slope of side BC, okay? So we're going to just take the slope of any two, okay, consecutive sides to see if those slopes would represent the line segments being perpendicular and therefore form a right angle, okay? So what kind of slopes are for perpendicular, okay? So same slopes means parallel. So hopefully you remember that negative reciprocal slopes prove perpendicular. So let's see what we get. Okay, so the slope of AB, again, slope is y2 minus y1 over x2 minus x1. So I'm going to, for example, go 3 minus 0 as the subtraction of the y's, and then in the same order, -2 minus -3 for the subtraction of the x's. So 3 minus 0 is 3. Add your opposite with minus the negative. -2 minus -3, or -2 plus 3 is 1. Okay, so let's see how that compares to the slope of side BC. So I'm just going to look at these y's. For example, I'm going to go 3 minus 1 for y2 minus y1. Then I'm going to go -2 minus 4, okay, for the subtraction of the x's. So 3 minus 1 is 2. -2 minus 4. Again, do your little add the opposite. That's -6. Now we're going to reduce this, okay? So 2 and 6 reduces down to 1 and 3. And you see that negative that's in the denominator? I can keep it in the denominator, or I can just move it up to the numerator because that's, kind of a little more common. So look at these slopes, okay? You see how these slopes are reciprocals of each other. The numerator and denominator have been switched. That's reciprocal. And you see how this overall slope is positive and this overall slope is negative. So they are negations of each other. So what that means is that AB is perpendicular to BC. And because the reason is you have negative reciprocal slopes. Okay, that's why you know that AB and BC were perpendicular. Now, just by knowing that you have yourself a parallelogram already, see, I already told you that it was a parallelogram. Okay, so once you know it's parallelogram, you'd know that these opposite angles would be congruent. You'd know that these consecutive angles would be supplementary. That would automatically make all four of those angles being right angles. So then you would just write this. You would say, okay, parallelogram ABCD is a rectangle because, okay, if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle, okay? And now we go for the other method. So you wouldn't have to do both. You would just in general do one or the other, but let's see what you would think about the other one. So we would want to prove using the distance formula. So remember, distance formula is square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. We would want to prove that the diagonals of the parallelogram were congruent, okay? So we want to prove that the distances were the same. So these diagonals are AC and BD, right? So AC, just don't put a bar over it, and that means distance. And then BD, again, don't put a bar over it, and that means distance. So let's see what they are, okay? Get yourself all set up to use the distance formula. Make sure that square root extends over your work the whole time. So A and C, okay? I'm going to do x2 minus x1, so 4 minus -3, and then 1 minus 0. Let's see what we get. So 4 minus -3 is 7. 1 minus 0 is 1. Now do the squaring, 49 and 1. Now do the adding, and there's square root of 50. So don't worry about simplifying that, okay? Let's just come over to BD, and we're going to just compare it. So looking at these x's, for example, I could do 3 minus -2. And then in the same order, I would do -2 minus 3. Okay, just always make sure you use the same order. So 3 minus -2 is 5, because you got adding the opposite. -2 minus 3 is -5. Again, you got adding the opposite. Notice I always keep my parentheses while I'm doing my work until I'm done with my squaring. So any number squared is always positive. So each of these is each 25. Now you add it together and that's 50. So there you go. We are looking at these two lengths being the same, which means that AC is congruent to BD. Okay, why are they congruent? Because they have the same lengths. And then what does that mean about this parallelogram? See, I was already told it was a parallelogram. It means that it's got to be a rectangle because look here, if the diagonals are congruent, that automatically means the parallelogram is a rectangle. So I write that down. I go ABCD is a rectangle because if the diagonals of a parallelogram are congruent, the parallelogram is a rectangle. All right, so that is what coordinate geometry proofs are all about. Again, this is our first of 3 days. We're not going to have as much going on the second and the third day. Just to let you know, the first day here is like the biggest of the days, and then it kind of, we just kind of work from here for the next couple days afterwards, the next few lessons afterwards. So, go back, pause the video, review it as much as you need to. Use it when you're doing your homework, and I'm just going to ask you to post the one problem from day 1 for tonight's homework. Okay, just the one problem and that's it. And then, Thursday of this week will be the second problem, day 2 problem. Then into next week on Tuesday again will be the day 3 problem. So, you can print out the whole packet at one shot. I'm going to be posting that each and every time, but just post, what's needed for each day. Okay, hope everybody is well, and hope you found that this was easily understandable. Bye-bye.